Dear students, today we have to start nitrocells and nitric oxide and its complexes. So nitrocell or nitric oxide acts as a ligand and coordination chemistry. It has been extensively used. Because of certain properties of nitrocell ligand or nitrocell compound, we can say, although this is not compound, and later on we are coming toward explanation of the nature of nitrocell, whether it is compound or it is any other species. So nitrocell is a quite attractive ligand, and since we are discussing the pi acceptor ligands, so on the basis of the topic of the chapter or title of the chapter, you should also be sure that nitrocell can probably be a pi acceptor ligand. So this nitrocell ligand, it is actually a free radical. As I told you, this is not a compound, but it is free radical. And this nitrogen dimer is actually, this is not possible. Uh, or it is extremely weak, and on the basis of this extremely weak bonding between nitrocell and nitrocell, the existence of dimer is questionable. It forms diamagnetic complexes whenever they are combined with metal center or metal fragment with odd number of electrons. And alternatively, this nitrocell used for nitrocell complexes is a cation, which is available in the form of this type of salt. Now we will also do some reaction. We'll study some reactions of this salt, that how nitrocell is introduced into the complex. What is the motto behind the introduction of nitrocell in a compound or coordination compound, and what properties this nitrocell will introduce, or what type of reactivity will be induced in the complex, or whether the complex will become more reactive or less reactive by introducing nitrocell to a particular compound. These all facts and these all things we have to explain in coming discussion. Now, nitrocell is cation. This is isoelectronic to carbon monoxide or carbonyl ligand and nitrogen. Isoelectronic species are those species which possess same number of electrons. So if you count total number of electron of nitrogens and oxygen, so nitrogen possesses 7 electron, oxygen possesses 8 electrons, so 8 plus 7 is equal to 15, and the species possess a positive charge. So now you can remove one electron, so 15 minus 1 is equal to 14. It means there are total 14 electrons with nitrocell cation. Carbon possesses 6 electrons and oxygen 8 electrons, so 6 plus 8 is equal to 14, and here also number of electrons was 14. So it means nitrocell, cation, and carbon monoxide or carbonyl, they are isoelectronic species. Similarly, one nitrogen possesses 7 electrons and the other one possesses 7 electrons, so 7 plus 7 is equal to 14. And these species are called as isoelectronic species. So whenever we are talking about isoelectronic species, so we can carry out similar chemistry on isoelectronic species. For example, if we want to remove carbon monoxide by any other ligand, so first of all we have to look for isoelectronic nature of that ligand. For example, if we want to carry out reactivity of complexes which bears carbonyl ligand already or nitrogen already, so nitrogen can be replaced by carbonyl or carbonyl can be replaced by nitrogen depending upon the nature of the complex and the medium or conditions being provided to the reaction. Similarly, nitrocell can be replaced by carbonyl or carbonyl can be replaced by nitrocell. So in this regard, we also have to discuss or to know about the strength of the ligand, whether nitrocell is a strong ligand, carbonyl is a strong ligand, or dinitrogen or nitrogen is a strong ligand. So they can oftenly be substituted by each other, and particularly carbon monoxide can be substituted by nitrogen or nitrocell based on this isoelectronic nature of these species. Then If the nitric oxide or nitrosyl is attached to a metal unit in a complex, so majority of this fragment is linear. So depending upon the geometry or electronic nature of this species, so linear fragments are afforded by nitrosyl. And nitric oxide cation, this is actually two electron donor as per ionic model. So we are coming to ionic and covalent model in while discussing the bonding in nitrosyl, metal nitrocells. So this we will come across later on, inshallah. And on covalent model, so it can be three electron donor. So nitrosyl can replace carbonyl while it is in plus one charge, and increasing the reactivity of the resultant compound due to an extra positive charge which is present on this nitrosyl. So carbonyl possesses no charge, and whenever neutral ligand is replaced by a cationic ligand, a positive charge is introduced to the system or to the compound, and this positive charge for sure increases the reactivity of the metal complex or fragment. This strategy is used for activating unreactive complexes of carbonyl. So whenever we have some complexes of carbon monoxide or carbonyl ligands which shows no reactivity, or they are inert under ordinary or even under harsh conditions, so what we have to do, we have to introduce a nitrosyl cation, and this nitrosyl cation will impart particular or special type of reactivity to that complex. Now coming towards some examples, for example, this is allyl species, and this is organic ligand. Actually this is CH and CH or C3H3, and this C3H3 possess three unpaired or pi electrons. So this ligand is actually three electron donor molybdenum complex with two carbonyl ligands and one CP ligand. So whenever nitrosyl in neutral state is treated with this compound, so no reaction is generally observed. While whenever this source is used, this salt, which is a source of nitrosyl cation, so NO plus, this is cation, and BF4 is anion. So whenever this salt is used, so this salt is used as a source of nitrosyl cation, and this nitrosyl cation actually is introduced into the system or into the complex. So now this complex, and what happens actually here, we have two carbon ligands, and here the only one carbonyl ligand remains and the other one is replaced by nitrosyl, and additionally a positive charge is also introduced into the complex. So on the basis of this positive charge, now this compound will be definitely more reactive, and whenever this is reactive, now it will react with nucleophile. And what this nucleophile will do, this nucleophile will now look for positive charge places or positively charged positions, and will get attached to the complex. So in this case, if we are treating it with nitrosyl and then we are treating the same species with a nucleophile, so we will observe no reaction. While when we introduced a nitrosyl cation, so this nitrosyl cation increases or enhances the reactivity of the complex, and the complex becomes sensitive toward nucleophile, and nucleophile ultimately react with the species to give a special type of products. What is a nucleophile? So nucleophile can be enamines or this Grignard reagents where aromatic group is attached. So this phenyl is actually a carbanion, or this is actually a nucleophile, and magnesium bromide as cation leaves the system or it is removed. So phenyl can be introduced at this end instead of by replacing this nucleophile. Now coming toward bonding in nitrosyl species. So bonding is exactly similar to carbonyl, or I am sure you are familiar with bonding in carbon monoxide. So we will also use some of our knowledge being adopted or being gained during explaining bonding of carbon monoxide. So the bonding is similar actually, but the only difference between carbonyl and nitrosyl is the difference of one electron and one